Hi, this is Mark from Red Planet Project. Mars is a world without ready-made infrastructure. If we want to survive there, we must secure our own energy. Without it, there will be no oxygen, no water, and no life. So today, let's explore what technologies could power the first bases on the Red Planet and what scientists are planning for the coming years. Let's get started. The first natural source of energy that comes to mind is, of course, the sun. Mars does receive sunlight, but it's weaker than on Earth. On average, about 43% less. That means solar panels on Mars will produce less energy than identical panels set up on our planet. But that's not all. Mars experiences dust storms, and not like the ones in Earth's deserts. Martian storms can last for weeks, sometimes covering the entire planet. During such a storm, solar panels can practically stop working. Additionally, fine dust settles on their surfaces, further reducing efficiency. That was the reason why the Opportunity rover, after many years of working on Mars, ultimately ended its mission. Its panels were covered with dust, and it couldn't wake up. So simply setting up solar panels on Mars won't be enough. We need systems that can handle extreme conditions. Scientists are considering automatic cleaning robots, panels covered with special coatings, and even vibrating mechanisms that shake off the dust. But every one of these systems means extra energy, extra cost, and extra risk of failure. What works well in a lab on Earth doesn't always survive the Martian reality. That's why scientists are proposing a hybrid approach, combining solar energy with other sources, like wind power. Surprisingly, Mars has winds. The atmosphere is 100 times thinner than Earth's, but even so, the wind has enough force to move lightweight structures. Wind turbines on Mars would have to be very large and very light, made from advanced materials. But simulations show that in some regions, especially near the equator, wind could be used effectively to generate power. Especially during dust storms, when solar panels fail, the wind could be our rescue. Hybrid systems, combining solar panels, wind turbines, and energy storage, seem to be the most realistic solution for the first bases today. Simulations suggest that such a system could provide year-round power on over 30% of Mars's surface. And with proper expansion, even half of the planet. But there are challenges here too. Storing energy on Mars isn't easy. Batteries must withstand extreme temperatures, cosmic radiation, and shifting environmental conditions. Every energy storage unit adds extra weight to launch, and transporting cargo to Mars is expensive. 1 ton of payload today costs hundreds of thousands of dollars. That's why the first systems must be as efficient, light, and durable as possible. Solar and wind energy can provide a strong foundation. But on Mars, we can't rely on just one source. We need redundancy, we need backup systems, and we need technologies that can survive long months without the possibility of repair. In the future, hybrid energy farms could become the backbone of Martian colonies. But to make that happen, we still have many engineering barriers to overcome, and we must face a planet that doesn't make anything easy. The second serious candidate for the main source of energy for future colonies is nuclear energy. Unlike solar energy, nuclear reactors are not dependent on weather conditions. They do not care whether it is day or night, or whether a dust storm sweeps across the planet. They provide stable, continuous energy production for many years without interruption. That is why NASA has been developing the Kilopower project for years. These are small reactors designed specifically for space missions. One such reactor, with a power output of about 40 kilowatts, could power an entire small base on Mars. The design is well thought out. The device uses a simple Stirling engine and a passive cooling system. Thanks to this, it is lightweight, compact, and free of complex parts that could easily fail in harsh conditions. Nuclear energy has huge advantages. Small reactors can operate for 10 years or longer without the need to refuel. They provide energy independence. They allow the base to function even during the longest dust storms. But nuclear power is not just advantages, it also brings serious challenges. The first is transportation. Launching the reactor into space and safely delivering it to the surface of Mars is an operation requiring absolute precision. Any failure during launch or landing could lead to a disaster. Damage to the reactor during the journey could mean not only the loss of the mission, but also environmental contamination. Another problem is safety on the planet itself. If a reactor on Mars suffers a serious failure, repair may be impossible. On Earth, reactors are monitored by entire teams of specialists. On Mars, in the first years of colonization, everything will have to operate almost fully autonomously. A failure of the cooling system, a crack in the casing, even a minor leak could contaminate the surrounding area. That would be a threat to people, crops, and the entire base. There is also the issue of radioactive waste. Even if the reactor operates according to plan, after its life ends, the spent fuel will need to be safely stored. Mars has no prepared facilities for storing nuclear waste. It will either have to be transported to special locations, or a way must be found to store it safely on site. Finally, there are important social and political issues. Who will manage the reactors? Who will be responsible for their safety? What regulations will apply in future colonies? Nuclear energy gives Mars stability. It enables development, independence, and the construction of larger settlements. But it also demands tremendous responsibility, perfect technology, and absolute trust in every part of the system. In the future, more advanced types of reactors are also being considered, such as molten salt reactors. These systems are self-regulating, harder to overheat, and less prone to dangerous failures. However, for today, if we think about nuclear energy on Mars, we must remember, it is a technology that does not forgive mistakes. Besides solar and nuclear energy, scientists are also working on new technologies that could completely change how we power bases on Mars in the future. One of the most promising directions is using the planet's local resources. One such project is MOXIE, a small experiment installed on the Perseverance rover. MOXIE proved that it's possible to produce oxygen directly from the atmospheric carbon dioxide on Mars. That's a huge step forward. Producing oxygen means not only the ability to breathe, but also the ability to create rocket fuel on-site, without the need to bring it from Earth. In the future, advanced systems like this could produce oxygen on an industrial scale, reducing our dependence on supplies from Earth and making it easier to build self-sufficient colonies. But the work doesn't stop there. Scientists are also developing technology to convert carbon dioxide and water into methane, which can be used as fuel. This process relies on electrolyzers operating at low temperatures. Such methane could power generators or serve as fuel for vehicles and return ships heading back to Earth. Looking further ahead, there's the idea of tapping into geothermal energy. If we could find active geothermal sources beneath the Martian surface, we could harness the planet's internal heat to generate power. This solution would be stable and long-term, but for now, we don't have evidence that Mars has an active enough interior. Another futuristic idea is building satellites that collect solar energy in Mars' orbit and beam it down to the surface using microwaves or lasers. Such an orbital network could provide a constant energy supply, unaffected by time of day or dust storms. This technology is still in the research phase, but one day it could revolutionize our capabilities. Finally, there are the dreams of nuclear fusion. If we succeed in mastering safe and controlled fusion technology, we'll be able to produce nearly unlimited amounts of energy with minimal fuel. Fusion is the process that powers stars. Bringing it to Mars would be the greatest leap in our civilization's history. But for now, fusion remains within the realm of research and experiments on Earth. All these new technologies show one thing. The future of energy on Mars won't come from a single source. We'll need many systems working together, supporting each other, and adapting to the planet's changing conditions. Mars will force us to be creative, and it's exactly that creativity that holds the key to success. As you can see, no single technology will solve everything. On Mars, we'll have to combine different sources of energy: solar panels, wind turbines, nuclear reactors, and in the future, maybe even orbital systems and on-site fuel production technologies. Energy will be the heart of every colony, and how well we prepare for these challenges will decide whether Mars becomes our second home or remains just an unreachable dream. Now, a question for you. If you had to choose one source of energy for the first base on Mars, what would you pick? Solar, nuclear, or maybe something completely different? Write your answer in the comments. Thanks for watching, and see you in the next episode of Red Planet Project.